Hello friends, welcome to my YouTube channel. Today I will show you how to create your own Raspberry music server. I designed my music server with two goals in mind: to have a fast, fully functional music server, to make it look as aesthetically pleasing as possible without sacrificing functionality. Now look at some supplies and tools and materials which are used in this project. Now step number 1, design. I have seen speakers with brass siding and so wanted to somehow integrate that into my music server. For the design, I first used Fusion 360 to model the speaker. From there, I created a 1:2 scale drawing depicting the dimensions of the speaker and its shell. Now step number 2, 3D printing. My printing settings were as follows: infill 20, printing speed 35, color red, filament PETG, filament brand Matter Hackers, printer model Lulspot Dash 5, printer extruder, temperature 235 degree, printer bed temperature 60 degree. Now step number 3, creating the main body. The process is quite simple. I used a table saw to cut two 10.5 inches into 3 inches rectangles. Using a jigsaw to round the edges, I routed the hole for the Pemoroni Pirate audio head using a router and a Dremel. Using Gorilla Super Glue, I then glued the back plate to the back of the plastic speaker shell. Then using a soldering iron, I slowly melted each spike mount into its place. Carefully, not to push it too deep, I drilled 3 more holes, one in the middle, about 1 into 8 inches above the bottom edge, and 2 more, one on the left and one on the right, about 1 into 8 inches below the top, to attach the front plate to the speaker. Lastly, drill 2 holes into the spots called holes for M2 bolts in the front plate. Now step number 4, brass. This is my first time working with brass, so please bear me as I outline the process for bending and soldering the brass. First, I cut the first two pieces of brass to 8-inch length for the top and bottom of the speaker. After cutting the third piece of brass in half of the sides, I then put the 3 inches metal pipe in a vise and tightened it securely for a mold to bend the brass sides. Before soldering everything together, I drilled the holes for the speaker spike mounts on the bottom brass strip. I also drilled 3 holes in the top brass strip with the 2.1 inches spacing to keep the brass together. I then used a Sharpie to mark out where the pieces will need to be soldered together. Using thick solder and a flame torch, I tried to solder together the brass. It took a while, but I managed to solder all 4 pieces of brass together. After all of that soldering, I sanded the outer side of the brass, removing any leftover residue from the heat and solder. I started with 120 grit sandpaper and worked up to 400 grit. Using some screws I had lying round, I screwed in 3 screws on the top and hand tightened the 4 speaker spikes on the top. Now step number 5, installing the software. This is the software installing process. To install the software onto your Raspberry Pi, first flash the Raspberry Pi OS to a formatted FAT32 SD card. Connect the power cable to the female end of the left angle micro USB and feed that through the hole in the back plate. After that, you can connect the male end of the left angle micro USB cable to the power connector on the Raspberry Pi. Now, step number 6, assembling the front plate. Images of the assembling process. Now that we have the software programmed and the brass attached, we will now assemble all of the components onto the front plate. Now turn off the Raspberry Pi, disconnect the pirate audio head and speakers, feed the speaker wires through the speaker hole, connect the female header to the Raspberry Pi. Now step number 7, conclusion. One improvement I might add in the future is to attach some brass mesh to the front of the speaker to conceal the speaker holes and screws. The process of making this media server is somewhat long and tedious, but I do believe the finished product looks quite impressive. Thanks for reading.